Hello, and welcome to the reteach for checkpoint 2. So if you got a failing grade or anything below an 85 on checkpoint 2, then this is for you to do as part of what you need to do before reassessing for checkpoint 2. So please take notes because I will check them off. You will use them for your reteach assignment, and you can also use them if you decide that you want to requiz up to an 85. We are going to be going over the review questions that I had posted on Canvas a couple of days prior to us taking the checkpoint, and I told you guys that you could work on them in class and use them as notes on your quiz. So if you didn't do that, then here they are. So starting out with this one, we have solve using complete the square. So yes, you do have to read the problems and know which process to use. That is part of the standards for the state of Texas. You do need to know how to complete the square. So starting with complete the square, what I do, I draw out my square. And remember, the goal of completing the square is that you want to have the same thing on both sides of the box. So I start out with x squared. I always start out with this first thing first. And so I know that outside of my box, I will have x and x. Woohoo! Then what I do with what's in the middle is I take it and I split it in half. So if you want to make a note of that to yourself, you want to split it in half so that we have the same thing in both of the diagonals. So that way I have the same thing on both sides of the box. I have x minus 3 on one side, and I have the exact same thing, x minus 3 on the other side. That's what I want for complete the square. You want the same thing on both sides. Okay, the same thing on both sides. Then what's going to go in this last space? So what's going to go in this last space is negative 3 times negative 3. I'm multiplying these two things, and that is 9. Now that's different because that's a positive 9, and this is a negative 9. So I have to think, what do I have to add or subtract from positive 9 to give me negative 9? I have to subtract 18. All right, so if I subtract 18, that's going to give me negative 9. So when I rewrite what's in here, this is going to be x minus 3 times x minus 3. And then we've got this minus 18 on the outside. And then this simplifies to be x minus 3 squared minus 18. So this is my new completed the square version of this quadratic. Now when I'm using it to solve, whenever I see solve, I'm going to want to set my equation equal to 0. When I'm talking about quadratics, I'm going to set the equation equal to 0. So now, with this next part, I'm going to rewrite this as 0 equals x minus 3 squared minus 18. And now I solve for x. So I'll start out with adding 18 on both sides. So that gives me 18 equals x minus 3 squared. And then I take the square root of both sides. That cancels out the squared on this side, leaving me with just x minus 3. And then square root of 18 will be positive or negative square root of 18, whatever that value is. And you might need to plug that into your calculator to figure out what that is. We haven't talked about simplifying radicals yet, or simplifying square roots, so we'll just leave it as square root of 18. And then we add 3 on both sides. So now I have two answers. I have this positive 3 plus the square root of 18. And I have my other answer, which is 3 minus the square root of 18. And so if you use your calculator for this, let's see. The square root of 18 is 4.24. So this would be 7.24. And then this would be negative 1.24. So now these are my answers. We have solved. And that's it for this first one. So this is the process of completing the square. This stuff over here is completing the square. And then this part is the solving. Moving on to the next example. Factoring. So with factoring is when we find A, B, and C. So my A, it's the number in front of the variable, my coefficient. So A is 7, B is negative 27, and C is negative 4. When I have A, B, and C, I look at A times C, which in this case is 7 times negative 4, which is negative 28. I look at factors of A times C. I look at factors of negative 28. And I see that my options are negative 28 times positive 1 or positive 28 times negative 1. 2 times 14. So 14 times 2 or positive 14 times negative 2. Negative 7 times 4 or positive 7 times negative 4. So when I go through the list, I am choosing which ones add up to negative 27. So if I go through this list and I look at negative 28 plus 1, I find right away that negative 28 plus 1 is negative 27. So I pick these. You can use the X if you want to. If we were to use the X, by the way, if you're one of those people who likes to use this, in the top, I will put A times C, so that's the negative 28. In the bottom, I would put B, which is the negative 27. And on the sides, I would put the negative 28 and the 1. So that's if you like this, if you like the X. But you don't have to do it. This is very much optional. Now, if we have the box, now this is where the box comes into play. The first term always goes into the first spot. So this is always going to be the first thing I see. Now with factoring, in the last spot, I will put this guy. And in the middle, I will put those two numbers that I chose, the negative 28 and the 1. They both just get an X with them. Because the goal is those two should add up to what's in the middle, the negative 27x. Now I'm just factoring. I'm looking at the columns and the rows and seeing what each thing has in common. So if I look at my first column, 7x squared and negative 28x, I see that both 7 and negative 28 can be divided by 7, and they both have at least one x. From there, it's like a puzzle. Okay, 7x, I would have to multiply with an x to give me 7x squared. With x, I'd have to multiply a 1 to give me 1x. And then out here, would have to be a negative 4. So that negative 4 times positive 7x would give me negative 28x, or negative 7 times positive 1 would give me negative 4. So from here, the stuff that's on the outside is, they are my factors. So my factors are 7x, and that's a positive 1. Since I don't see a minus sign, I assume it's a positive 1. And then I've got x minus 4 equals 0. So now I use these to solve because I can take each factor and set it equal to 0 and just solve for x. So one of my answers is that x equals negative 1 over 7. And then my other one is that x equals 4. So these are my two answers. And that is how you factor. So this is the factoring part. And then this is where we solved. Right? Moving on. Solving. We've got a square root equation. I always want to look at the square root. Okay, I want to get rid of the square root. First, I check if there's anything outside of the square root. So out front of it, we don't have anything, or anything that's being added or subtracted that isn't underneath the line. We don't have any of that. So we need to start out by getting rid of the square root. You cannot do anything with that negative 7 until you get rid of the square root. So in order to get rid of a square root, we have to square both sides. So I square, that cancels out the square root, and then I've got x minus 7 equals 12 squared. And if we do 12 squared, or 12 times 12, that is 144. And then from there, to get x alone, we add 7 to both sides. And then 144 plus 7 is 151. And that's it. That's all you really have to do there. And then we have our most intense type of problem, which is solving a square root equation where you have an x underneath the square root and where you have an x on the other side of the equal sign, not underneath the square root. So what happens there is we'll have extraneous solutions at the end, meaning we will have solutions that actually don't work out when I plug them back in to the original. So this is my original. This is very much my original equation. When I'm solving, I want to get the square root alone. So to start out, I'm going to subtract 5 on both sides. And so I end up with x plus 1 equals x minus 5. Now there is nothing on the left-hand side of the equation that is outside of the root, so I can go ahead and get rid of the square root now. So I square both sides. And that gets rid of the square root. So I just have x plus 1 equals x minus 5 squared. Now when I have something that is squared, that is that thing times itself. And so what I do here to multiply these things is I use the box. So x minus 5 times x minus 5. X times x is x squared. X times negative 5 is negative 5x. And x times negative 5 is negative 5x. And then negative 5 times negative 5 is positive 25. So when I rewrite this, This is x squared. Minus 5x is minus 10x. And then that positive 25. And I have x plus 1. Now this is no longer a square root equation. This is a quadratic equation because I don't see the square root anymore, and I see that I have an x squared in here. So whenever I have a quadratic equation, now I solve it like a quadratic, meaning I have to have it equal to 0. So I'm going to subtract x and then subtract 1 from both sides. And this will be 0. This will be x squared minus 11x, because negative 10 minus 1 is negative 11. And then this 25 minus 1 is just 24. Honestly, from here, we're at a point where I don't care how you solve for x from here. Nowhere does it say for a square root equation that you have to use factoring to figure out what x is. Once you get to this point, you pick your poison. You can factor, you can complete the square, you could even use the quadratic formula. In this instance, factoring is going to be the easiest. If you don't want to factor and you just want to use the quadratic formula, that is fine. Do what you want from this point. I don't care. I would factor though. So A is 1, C is 24, so my A times C is 24. I already know what's going to add to 11 here. I already know it's going to be 8 and 3, but since it adds up to a negative 11, it has to be negative 8 and negative 3. And I already know what this is going to be. I'm pretty much just doing this for people who want to factor, but that doesn't have to be you. So this would end up being, you could even graph this in Desmos for all I care, honestly. For this type of problem only. So x would equal 8. What the heck? X would equal 8. X would equal 3. So these are my two answers, that x equals 8 and x equals 3. But you have to check. You have to check for an extraneous solution. So what that means is when I take 8 and I plug it back into my original, right, I want to see that both sides of the equal sign are right. So I'm seeing if square root of 9 plus 5 is 8. If 3 plus 5 is 8. You could always use Desmos to help you out here, but 8 is 8. So 8 is valid. Hooray. But if I do this same thing for 3, let's see. 3 plus 1 is 4. Oh my goodness. Look at me. Look at me a mess. I'm checking that it all equals 3 at the end. 3 plus 1 is 4. Square root of 4 is 2. 2 plus 5 is 7. 7 does not equal 3. Not valid. Okay, so you have to plug these values at the end back into your original equation and see if both sides of the equal sign end up being the same thing when I plug that number back in. For 8, it worked out. For 3, it did not. You do have to check. You don't have to know how to do this math by hand to check. You could use the calculator to help you figure out what the square root of a number is. That doesn't bother me. But you have to know how to check. Okay? With that, if you have any other questions, please let me know. You're going to see a lot of similar problems for your reteach practice before you come in and take a retest. If you decide not to take the retest, that's fine, but you still have to do that practice if you want me to raise your grade. And also, this will be good practice because this stuff is going to be on your test. Okay, thank you very much, and have a wonderful rest of your day.